click, off, click your nitrile gloves. Discharge. Hello and welcome to StarBorn Science. Today I will be showing you how to prepare a compound I have named Lumi Cyan. A subscriber of mine asked after viewing a short video how to prepare it, so that's why I'm here today making this video for you to show you how to prepare it. So let me go over the synthesis really fast. What we do is we make a schiff base, which is a condensation reaction between an aldehyde and a primary amine, in which the nitrogen of the amine replaces the oxygen in the carbonyl of the aldehyde with nitrogen, and forms what's called an imine, not an amine, an imine, which is a base called the schiff base, which can form salts with metals. So we use vanillin as our aldehyde, ethylene diamine as our base, as our amine, and we form the schiff base of vanillin and ethylene diamine, and then we add a trivalent metal. In this case I add aluminum trichloride, and then we precipitate this salt, and then after drying it we extract it with isopropyl alcohol, then irradiate it with ultraviolet light and oxygen, meaning with atmospheric air of course, for about 1 day to activate it fully, and then we just add a few drops in some isopropyl alcohol and we got a cyan fluorescent solution. So that is the overall synthesis. Now let's go cook. So here is everything that we'll need. Here is pure vanillin. This should you be very careful with. This is aluminum trichloride and reacts very violently with water. This of course is isopropanol. This is more isopropanol. This is a solution of 50% in water of ethylene diamine, because we do not want the schiff base to form a solid. We want it to be formed partially in water. This is to measure the ethylene diamine, and this is the beakers in which we will prepare the two solutions, and this is more vanillin. So because I will make 2 batches. However, only one batch will make it into the end, because I'm like that, you know. So I decided to go with this type of vanillin and make one batch, because this is the most commercially available vanillin you guys will probably be able to find. So I wanted to make it as DIY as possible, because many people won't have access to pure vanillin. So I went with baking vanillin, which may contain other traces of materials, so it will be dissolved and filtered in isopropanol. So let me do that, and we'll go on from there. So each little vial contains 500 milligrams of vanillin. It's almost pure, so I add 4, so it's about 2 grams of vanillin in there. I don't know its purity, maybe about 80%. So I'm gonna leave the pure stuff over there, and we will work with that. Now, keep in mind, pure vanillin completely dissolves in isopropanol and has a very high solubility in it. So this should completely dissolve, but it won't, because it's not pure. And I'm gonna save you the time and dissolve it, filter it, and proceed. So now I'm filtering the solution. It's coming out quite clear, as you can see. All the vanillin is in there, all the fillers, the starches, anything else they add is well, in the filter. Now our vanillin is in there, in the isopropyl alcohol. Now keep in mind, this is a condensation reaction, so adding an aqueous solution of the ethylene diamine won't form the full schiff base. The full schiff base is a solid, and it's not soluble, so we're forming a partial schiff base of the ethylene diamine vanillin condensate. So you will notice a color change. I'm adding 3 milliliters of 50% ethylene diamine water solution, and you'll notice a yellow color change. This is our schiff base, our partial schiff base forming. And there you go. I'm gonna keep stirring for some minutes to give this a chance to form fully. And now I want your attention here, because this is the most dangerous part of the synthesis, where we add a small quantity, about a gram, of anhydrous aluminum trichloride or aluminium trichloride, if you're European like me. And then we add water, and there's going to be a violent exothermic reaction. If you notice, I have the fume hood on, because there's going to be hydrogen chloride released. and also water vapor mixed with it. And we want a concentrated solution of it. Yet we can't use it as is, because as it is really hot. We need to cool it in the fridge first and then mix it with our schiff base solution, our partially formed schiff base solution, that is. Now, as you can see, the color has become a more bright yellow due to the imine forming and being more concentrated in the solution. As time passes, this will darken more and more. However, this is a good place to stop. We've got enough imine in there to form our complex. Now it's time to actually put the aluminum trichloride solution in the fridge and let it go at room temperature. Then mix the solutions and proceed to the next step. Also note that this is not fluorescent right now. It will only become fluorescent after we add the aluminum trichloride to it, or any other trivalent metal ion like dysprosium, europium, samarium. It doesn't matter that they are rare earth metals that do fluoresce on their own. It has to be a trivalent metal, even chromium, anything that is trivalent. Don't ask me why, I don't know why. This compound, I've searched online for some paper, for something, nothing exists. I don't know if I discovered this on my own. I really would like to take the buds, but I don't wanna claim copyright since I do not have any information on it. So, trivalent metal ions, that's what works. Don't ask me why. I don't know what actually happens. I know what happens till this point. After this point, I'm lost as well. Someone once told me not to put all my eggs in the same bucket. So here is the aluminum trichloride. It's kind of ice cold. And now I'm gonna add it into the schiff base solution. And we will observe a precipitate form. Now we've got to filter this, dry it and extract it with isopropanol. If my camera focuses, you will observe now the filtrate is fluorescent suddenly. If I hit it with my UV torch. It has a pale cyan fluorescence, though that's nothing compared to what's coming. Now, if you observe it, it has a kind of greenish fluorescence to it, but that will change once we extract it with isopropanol. And our powder is dry, and now we will proceed to extraction with isopropyl alcohol. And I'm going to add about 20 to 30 milliliters. And start stirring. We do not need heat for this process. And one good clue to see if your solution is active is to heat it with a UV beam. And as you can see, if I turn the lights off, the solution is fluorescent. Let me turn this light off too. Maybe it doesn't show on the camera very well, but the solution is fluorescent. So that's a very good indicator that we have the fluorescent species in there. Now this extraction process will take about give or take 10 minutes. So after that we will evaporate some of the alcohol to concentrate the solution, and then we're gonna have to age it in order to activate it in front of the UVA lamp. Now of course I can't time-lapse a day of aging due to memory issues, of course, of my camera and processing power of my PC. So I'm gonna show you an aged solution, that's all I can do, and you'll have to trust me that this is the aged solution. So that's the best I can do for you, to show you the comparison between an aged and a fresh sample. However, a fresh sample is still fluorescent enough to show you that it is fluorescent. I said aged, well, it's not wine, the correct word will be irradiated, and also it has to be in the presence of atmospheric air in order for this to work. So you'll have to keep this in a vial or a flask or whatever, a glass container that UVA can pass through, and also it has some atmospheric air in it for this to actually be transformed by some kind of photochemical reaction, which I also do not know, because I don't know what this is, so I don't know what happens also when it's irradiated under the presence of atmospheric air. I'm sure some kind of reaction with oxygen happens. But what happens and what this is, don't ask me. All I know is that it glows a beautiful cyan color, and it's prepared that way. So yeah, if you find what it is, tell me, I'd be glad to know. So now it's time to filter the solution, simply through gravity filtration, nothing fancy. And as you will observe, a non-irradiated or aged, or whatever we wanna call it, solution has a clear color to it, whereas a mature solution has a yellow tint to it, looks like piss. And of course it's fluorescent now, but not close enough to what sample will be. Well, now it's the paper that's stealing the show. I'll show you in a while. Now, this is the filtered solution under normal light. As you can see, it's a clear solution. Now, when I heat it with my UV torch, as you can see, it's a greenish blue solution. And this is our concentrate. Now, this has to be aged under UV. Now I'm gonna transfer this into a vial and compare it with an already aged solution. And this is how the diluted sample of the concentrate shines near the UV lamp. As you can see, it shines like how the freshly made concentrate shines. So that's why I'm saying the concentrate needs the irradiation step. It's really important. As you can see, even heating it with my torch made it a little yellow, while the aged solution has that already intense peace yellow color. And with the torch, this, you can see, self-quenches its own fluorescence. It's really intensely fluorescent, while this still the beam passes through the whole sample. Now, when this will be irradiated under even this little amount of oxygen for one day, will turn into this. Don't ask me why. Now, how do I irradiate it? Well, I have a simple CFL lamp where I place my solution over here and leave it there for one day, maybe some more. Once I see the color change, come to the right step, and then I know it's done. So this is how you prepare this stuff. If I place the other sample, you'll see, of course, the color difference. It's much more bright, whereas the other looks dull. As you can see, the other solutions are the diluted solutions of the concentrate, and they look all cyan, hence the name Lumi Cyan. Lumi because, well, Lumi is my bestie, and Lumi because also it's luminous, and cyan because it's cyan. So yeah, so I have to clean up over here, but let's review the procedure. Let's take this random knife over there. We're not knife people, we're science people. So, the synthesis of Lumi Cyan. Condensation, partial condensation of vanillin and ethylenediamine in isopropyl alcohol and some water, from the ethylenediamine being a 50-50% solution in water. Addition of the trivalent metal, the aluminum trichloride, in water. Precipitation, probably of its salt and hydroxide, I suppose. Drying of the product. Extraction in isopropyl alcohol. Irradiation in UVA and in presence of atmospheric air, which in my opinion oxygen is what does the transformation, along with the ultraviolet radiation for about 1 day, maybe 2, depends, and then you get the concentrate. So how does the concentrate behave, you might ask? Well, you can watch my short video about that, but I can also demonstrate. So I will demonstrate. So here I have my torch and isopropanol, which is not fluorescent by nature. What you see is the light scattering, the blue of the emission wavelength of the LED, because of course it does not emit only UV light, it emits some blue light too, and that what you see is light scattering. And now I'm gonna take with some syringe a small amount of the concentrate, the mature concentrate, and dropwise add it into the solution. And I added a lot. A few drops would do, actually. This is too much. But anyways. And as you can see, the thing is overexposed. Let me turn down the power of my flashlight a bit. So you can see the thing is a very high quantum yield fluorophore. I don't know what I made, but well, let's say it fluoresces very, very strongly. So yeah. That's Lumi Cyan for you. So thank you for watching this episode of StarBorn Science. I hope you enjoyed it. I hope you learned something. I hope you can teach me something. Keep dreaming. keep exploring, and I will see you on the next one.